Welcome everybody, my name is Aaron, and in this video we are continuing our tower defense game, which is actually meant to be more of a Python tutorial where I demonstrate you core concepts and ideas about programming in Python. I chose the tower defense game because it's relatively simple but a lot of fun to write and watch. In case you missed the previous videos, we already generated a maze and we have filled it with enemies, so we can now have enemies that just go around randomly. Let me show you what the game will look like after this video is done. So by the end of this video, we will have a lot of enemies. They will have health bars, which is actually not that new. But watch this, if I click one of the walls, because we're installing turrets on the walls, we have 4 different kinds of turrets, but in reality only 2 of them work. I'm gonna install a sniper turret, and you can see that the sniper turret has a range and it is attacking the enemies within its range. You can see how it's reloading, and after reloading it fires a shot, and 2 shots take out a creeper. So that's what our game will look like at the end of this video. Let me show you how. Okay, first of all, the health bar of the creeper, which I think is a very minor thing, but it is important when you're doing something that people are actually gonna watch to make it better. The thing is, the creeper did not change at all. It is exactly the same as it was before. If you're watching these video series in the playlist, you can check the previous one where we actually created the creeper. It looks exactly the same. How is that possible? Because the creeper inherits from the enemy base class, and the enemy base class is the one that has the implementation to move pixel-wise, because in that version, the creepers were moving block by block. The way this works is the core data did not change. Each enemy still has a position where they are at. However, now I have added the position where they are actually moving to. And obviously it's right next to the current position and it's a free space. It cannot be in any other way. But what I did was I took the draw function and made it a little bit more detailed. Let me put it this way, okay? We get the pixel coordinates. So if you have knowledge about the previous version, it always just took the block that we need to draw into. Now we have a pixel coordinate calculation function, the heart of which is this proportion. So the way this works is we have a number of ticks, let's say 60 ticks, that takes for the enemy to move from the current block to the next block, to the target block that it's moving to. Meaning that if since the beginning of this movement 30 ticks have passed, then it has to be halfway through, right? And we actually draw it halfway through. The way we do this is we take all the ticks to move, which is 60 by default, you can see it here. And we take the actual countdown where we are at, which is spinning down, and divide it with the number of total ticks to move. So if we are, let's say, at 15 ticks, since the movement command was issued, then we have 60 minus 15, that's 45. 45 minus 60, 45 divided by 60, it means it's 3/4 close to the beginning point and 1/4 away from it, so it's moving 1/4 away from the source position, the start position, and moving towards the end one. And we're doing the same thing for row and column. The same proportion is used, and that's how we can make the movement pixel smooth. Let me show you again that you can see that the creeps are now moving pixel smooth. However, please note that this is only a visual eye candy. In reality, when the creeps are on the way, they still count as being in the source, the original location that they are at. Why is this important? Because when we are writing the turrets that fire at them, we need to determine if the turret has actually hit this enemy or not. And when we are determining that, we still use the source position, the starting position of the enemy, and not the destination position, which means that if an enemy is just 1 pixel away from its destination, where it will be hit by a turret, but there is 1 pixel left, it will not be hit. This is a visual annoyance it's fine. Most people don't notice it. If you take a look at your favorite tower defense game, I am willing to bet that the same is happening there. Okay, that out of the way, now we know how the enemy is updated. And the only other difference is that we now have a maximum health and a current health. I forgot that in the previous iteration. Obviously, we need to know where we start from, and then we need to decrease the health of the enemy. So we are drawing a body for the enemy and an HP bar or health bar for the enemy. The reason for having these in separate functions is that the creeper still only needs to override the body drawing function, which would be a red rectangle by default, if you remember that part from the previous video. But we don't have to bother about the HP bar. It's just there. We don't have to care. The HP bar actually is 2 bars. Again, the same proportional system, the ratio is used. The current health divided by the max health. Obviously, if the current health is the max health, then it's green because it's multiplied by 1. If the current health is half of the max, then it's half green. And then the second one draws a half red bar. So this is what makes it really pleasing. And it looks like the green is revealing the red, but in reality, we draw one part green and then the other part red. Okay, that's what happens here. By the way, the game is open source. The link to the Git repository is in the video's description. Please feel free to check it out and just play around with it anytime. Okay, this out of the way, let's move to the actual game part, which is creating the turret. Of course, just like the enemy did, the turret begins with an abstract base class, or ABC for short. We will never create an instance of this turret class. It doesn't have all the implementation details in place. All it does is it does the boilerplate work to have a turret on the screen, okay? And it has a default position, which we will never actually use, the block size the same, and then a default color, and these ones are important. The range, the damage, and the ticks to attack. The range in blocks, so in the maze blocks, not pixels, that the turret sees enemies within, right? And we are going to indicate this with a circle, so it's visibly more appealing. The damage is when the turret fires and hits an enemy, how much health reduction does the enemy suffer. And the ticks to attack is how often does this happen. And the same mechanism works as worked with the enemy's movement. We have a countdown variable, and each time that countdown reaches 0, we do the damaging part, fire the shot, and start the countdown all over again. And this this turret needs to know where the attacked enemy is, okay? So don't forget that the pixel-wise scrolling is just a visual eye candy. In every moment, every enemy is in one specific block, and our turret obviously is also in a specific block, so it's super easy to calculate if the enemy is hit or not. And then the enemy shifts to another block, but still the same calculation applies. So we don't have to handle corner cases or that kind of stuff, okay? And then this one here is, again, an eye candy. Let me show you again what happens when a turret fires, and this time I'm going to use a different turret because we have 2 now. The machine gun. The machine gun has a much smaller radius, but a much faster fire rate. Of course, a much lower damage, but you can see this tiny little line that happens when a shot is fired. This, I think, is super important for the users to see that their turret fired and hit the enemy. And this is what I regulate with this visible ticks. So the shot is visible for this many ticks. Again, we are running at 60 FPS, meaning 60 ticks happen in 1 second. 3 ticks is a very small fraction, 1/20th of the second, but still it's visible but not disturbing on the screen. Again, open source, feel free to change it if you don't agree. Okay, drawing a turret is a little bit more complicated than drawing an enemy was, because we need to draw the turret's body that is residing wherever the player put it. We need to draw the attack line if the turret is attacking and the attack is still visible. We need to draw the turret's range, the circle that shows where the turret is actually capable of hitting enemies, and the remaining ticks, which again, if you have a look, and I'm starting it again, and it's fine, under every turret, putting up a sniper, it's more visible there. You can see when it's going to fire its next shot. A green bar is slowly being filled. Of course, it's getting bigger and bigger with each tick, and when it fills, that's when the weapon reloaded and it fires. I'm gonna put a machine gun here just to show you that if there is no enemy within its range, it loads and then waits for an enemy to come nearby. So this also works as you would logically expect it to work, and this is implemented in this turret remaining ticks drawing, okay? That's what draws the bar. Even though we don't have any intention to move the turrets now, I still implemented the pixel coordinate method, which just returns the pixel position of that specific block where the turret is at. Maybe later we're gonna have moving turrets, I don't know. It's better safe than sorry, right? It's kind of preparing for the future. Again, this turret body, which is a rectangle, this will never be called because this is an abstract base class. I implemented it, so if somebody forgets to implement it, we still see something of the turrets, which by the way I did, so it's kind of useful. And then the remaining ticks is a bar with a specific color that is below the turret, so under it, and shows where the loading process is. When the bar fills, that's when we are ready to attack. So we are using this countdown divided by the ticks to attack, which is the ratio that we need to wait for, right? And then the attack line, it has the same countdown mechanism. If the countdown goes to 0, then we remove the need to draw a line. We are no longer attacking, the attack is over, and then we completely finish there. If we do have a countdown to happen, so we are still making the line visible, then we obviously decrease the countdown, check to make sure that we do have an actual target, and then draw the line from the middle of the turret to the middle of the attacked enemy, okay? So it's always from middle to middle. Whether it looks good or not, open to debate, but that's what I did right now, and the line width is 1. That's how it works, okay? And then the turret range is just a very simple circle, the middle of which is in the middle of the turret itself, and the radius is the range of the turret in blocks, multiplied by the block size to make it actual pixels, and it's also a very thin line, okay? That's what it looks like. It's drawn with the same color as the turret is, has no real significance, I think. Here comes the important part, the attack method, if you are not sleeping already. For the attack method, we're using the same countdown mechanism, so we check if the ticks have actually expired, and then we go through all the enemies, searching for the enemy that is actually in range. There could be other methods to do this. We could use list comprehension and many other things. In this case, I decided to use this approach. And then once we find an enemy that is in range, we take the first enemy that is in range, okay? Which is, since the enemies are scattered through the maze in random, it's basically a random enemy picking. And then we reduce its health by the damage that we make. And note that we are making sure that if the damage we make is greater than the health the enemy actually has, then we only reduce the enemy's health to 0. And then we get the enemy's pixel coordinates that we actually register as, you know, to draw the line, the attack line. And then we say that we need the shot visible for as many ticks as set by default, okay? And then we reset the attack countdown counter for the next attack to happen. That's all we need to do. If we found one enemy, we just stop right here. Note that if there is a turret in the future that can actually attack multiple enemies, this code will not work. Then we need to re-implement this function, okay? But by default, if a turret attacks only one enemy, that's perfectly enough. And then the only thing left is the in-range function, which determines if the enemy is in range, and that's very simply the Pythagorean theorem. Not gonna explain that, I think it's quite self-explanatory. I have this debug message here that I absolutely do not need, so I'm removing it right now. Note that each time I save my code, the Python formatter black runs on it and reorders everything, that's fine, get used to it. And in case you are not familiar, this double asterisk is the power function. So double asterisk 2 means the quadratic power, and double asterisk times 0.5 means the square root of the given number. The Pythagorean theorem says that, so that's fine. And that's what an abstract turret looks like. And now watch how easy it is to create the actual turrets that we have. The machine gun has nothing, just a constructor. It calls the constructor of the turret, which we have inherited from, and then all it has to define is its own color, the range that it's capable to target enemies in, and the damage that each attack does, and the ticks to attack, meaning how many times a second it can attack. A machine gun has 30 ticks to attack, and since we are running on 60 FPS, that means 2 attacks per second. Let me show you the sniper, which is equally simple. It obviously has a different color. To be very honest, I just made up these colors. Like, I'm not good with colors, let's just put it this way. But the range is much bigger, the damage is much bigger. However, it takes 120 ticks to attack, meaning 2 seconds for one attack. So for the last time, let's see what this all results in. Oh, by the way, there's one more important step that I forgot. How do we actually create these turrets? First of all, let me show you how the game is initialized. And I'm going to close the functions that we don't need just now. We're going to expand these one by one. Okay, so when the game is started, then we just create a game instance and we call the start function. To be very honest with you, I think this line is unnecessary, but it's fine. It was generated by AI, so it's okay. So the way this works is we are using the Pygame library, and that has an init function that is mandatory to be called. And then we need to create a display, a screen, which is the window in which the game runs. And we make the caption Eternal Stronghold. And then we call the generate enemies, that generates all the enemies obviously, and then we just loop, okay? Let's see what the loop looks like, because that's the actual heart of the game. First, we check all the events that happen. There is an event called quit, which can be triggered by pushing the X, Alt F4, many other ways. Whichever happens, we just set the running flag to false, and since this loop only runs until running, it just makes the function return. And then there's the mouse button down function, which is the left mouse button, in case you were wondering, that actually calculates which block you clicked at. So the top left corner of the window is 0. And using that information, we can calculate, we get the pixel coordinates where the mouse click happened. Dividing that with the block size, we get the block where the click actually happened. And if that is a wall, because you can only place turrets in a wall, we select a turret. I will show you that in a second how that is done. If the turret selection was successful and the selected turret actually exists, then we instantiate that turret class, okay? And I'm going to show you how this is done. It's a little bit tricky, but very Pythonic. And then we place that turret, set the position of it to that column that you actually clicked, and put it to the list of turrets, okay? That's all. And then, after all this is done, so watch that this for loop ends here. In each loop, meaning each tick, we are making all the turrets attack. What does the attack do? Let me show you in case you forgot, which is perfectly understandable. It checks if the countdown expired, and attack actually performs the attack only if this required number of ticks have already expired, okay? And then after the attack has happened, we might have dead enemies. We use list comprehension. We go through the list of enemies, and we only keep the ones that actually have health greater than 0. So that's how we reconstruct the enemy list in each step. Maybe not the most efficient solution. We could pop the enemies that are dead, but it's fine. We don't have that many enemies that this is an actual performance penalty would happen. And then each enemy can make its move, which means that countdown expiry is verified, and whichever enemy's countdown is at 0, they can make the move. Same thing as the turrets did. And then we draw the whole game out, meaning the maze, the enemies, and the turrets, which draw the attack lines. And here is this Pygame function, where we actually make sure that there are only 60 ticks in a second, meaning the game runs at 60 frames per second, or FPS. You can obviously change this number to your liking and then everything becomes much faster, but that's completely up to you. And when this loop is over, we need to invoke this Pygame quit function. I honestly have no idea what it does, but that's the point of Python programming. You get libraries, the libraries take care of their problems. You don't have to worry about those too much. Let's take a brief look at how the game is actually drawn. First, the entire screen is filled with white. On top of that white, the maze is drawn. Then all the turrets are drawn, and then all the enemies are drawn. All this operation happens in something called a frame buffer. It's not happening on the screen because it was flicker real badly. It happens in memory on an image not visible to the user. Everything happens on that frame buffer, and then this flip function flips the visible frame with the in-memory frame. So when you call the init function of Pygame, it creates two frames, the visible one and the next one. You always work on the next one, you always work from scratch, so you always have to create everything from scratch, and then when you're done, you do a switch between them. And then the new frame is displayed, it becomes the current frame, and the other one is cleared, and that is your next frame that you can start drawing. That's how it works, very elegant. It's been like this for over 30 years for sure, but maybe more, okay? So that's how we draw the game. It's really not that complicated, I think, other than these technicalities. Generate enemies is also super simple. What we do is get a random empty space within the labyrinth, and then we create a creeper, which is an enemy descendant, put it in the random column and row, and put it onto our list in case you might not remember. Self enemies is just a simple list that we have created here, and lists have this append function that adds an element in there. Now, watch this. This is tricky a little bit. How do we take care of turrets? The thing is, we have a turret list, which is the name of the turret, and we have a set of turret classes. And remember that in Python, we have classes and instances. Class is the description of what an object should look like, while the instance is an actual memory space reserved for that class. For that instance of the class, okay? So the class is a map on what variables does that class have, and the instance is the actual memory space where the variables do store their values. And so these are the classes, these are the recipes or the maps of those specific classes. And what I can do, and I am doing here, is I am calling these as functions. And if you remember back, when you call a class as if it was a function, that is actually calling the init, and it will return an instance of that specific class, okay? So this is the only kind of tricky part, that we are storing the classes and we are calling them as functions, and thus we instantiate an instance from that specific class. And we are storing the instance in the turret variable, which now has variables, so I can go ahead and set it to the proper position. Let me know in the comments if this explanation was not clear enough for you, because this is a tricky part, that you are storing a class as a variable and then calling it as a function, which results in an instance. You need to wrap your mind around this, but this is a very Pythonic way of thinking. In reality, everything in Python is an object. The class is an object, the instance is an object, and that's why you can do the string is an object, the list is everything is an object. That's why you can do these kind of tricky manipulations to them, okay? Brilliant. Okay, that's exactly the thing that I wanted to share with you right now. And just one more, if you go ahead and launch the game, you can see that it works. And if you click a wall, you get this list, which now you know comes from the text. and I'm placing a sniper here, and I can see the radius because the draw function is drawing the radius of the range of the sniper. I can see the ticks to fire. I can see that upon firing, we draw the line, which also has a little countdown to make it appear and then disappear again. And then we are doing the damage. You can see that we're doing 50 damage. And the reason that this specific creeper was hit next is that in the list of the enemies, this was just the next one. It looks like random for the player because we don't know which creeper is which. We could put a number on them or whatever, but we don't really care. But in reality, it was the order in which they were generated by the create enemies function, okay? And the actual difference between the sniper and the machine gun is the range, the rate of fire, and the damage. So I'm just gonna go ahead and put a machine gun here. There you go, so that this guy gets killed as well. This is still not a game because there is no beginning, middle, and end. You have no destination. The gamification part itself is missing, but that's fine. We're going to do that in the next video. Thank you very much for watching. I hope you enjoy how this whole structure starts building up and looks more and more like a game. I personally love this process. I really think this is the most fascinating thing about software development is when you see your system become more complex, more intricate, more detailed, and it starts to have a behavior that is actually your brainchild. I really, really love this process. I hope you guys feel the same, and I hope I will see you guys in the next video, which will come soon. Thank you for watching. Bye.